My name is Heather Urbanek, and I'm going to start off the conversation with a little bit about Corning. So my company is Corning Incorporated. We're one of the world's leading innovators in materials science. We've been around for about 170 years. Corning has applied its unparalleled expertise in glass science, ceramics, and optical physics to develop products and processes that have transformed industries and enhanced people's lives. So we play in the spaces that you can see up there: optical communications, fiber optics, display devices such as television sets, and things such as pharmaceutical technology, so all things glass and ceramics. So I'm going to talk a little bit about the data lakehouse during the challenging times that we've had over the past couple of years. Manufacturing has had challenges since COVID, and now more than ever, we need to leverage advanced tools and larger data sets to better analyze where our opportunities are. First, a little bit about myself. So in September of 2019, I actually decided to take an expat assignment to grow a digital team in Shanghai, China. Previous to that, I had lived in Taiwan for about 6 months on an assignment for a plant expansion, actually in Wuhan, China, and decided to take an opportunity for my daughter and my husband to travel here and have a new cultural experience in China. We enjoyed Shanghai and the modern city and all that it had to offer. We went to Disney Shanghai. You can see Tron, the Tron ride up there. And 1 week in December, we'd heard about a small viral outbreak in Wuhan, which is about a 9-hour drive from Shanghai. But it didn't really pay it much attention at the time. But by January, China was starting to get more nervous about the outbreaks and started installing temperature sensing stations as well as canceling flights out of China. We had been actually planning to take a trip for Chinese New Year, and at that time it was a very complex situation to actually get out of China. And so we luckily were able to get out of China on one of the last flights in the end of January of 2020, and essentially I couldn't end up going back as a result of everything that was going on. So it really did sort of cause a lot of chaos in my personal life. And I want to talk a little bit more about what it did to Corning and other manufacturing companies as well. So in addition to impacting the personal lives of millions across the globe, COVID had an enormous impact on manufacturing. I think of all of the manufacturing companies that I saw while I was in Shanghai, including Nissan, Tesla, Johnson & Johnson, and Corning. And some of the first impacts that we saw were when, for Corning, we develop a lot of materials for automotive as well. We do automotive glass on the interiors for the touchscreens and other devices. And so in order for us to do that, right, the companies need to be selling cars. And you can't sell cars without chips. And unfortunately, many of the Taiwanese companies stopped manufacturing those chips, and that created a chip shortage. And it impacted many industries, including most of the automotive manufacturers and companies like Corning, who actually support those automotive material manufacturers. Workers were exiting the job market or staying home, and that caused labor shortages for us. And so we were decreasing the manufacturing of many products that we rely on. And these shortages caused increased demand on smaller number of suppliers. Prices started going up, and then that impacted manufacturers as well, because now we had to raise prices for everything that we manufactured to offset those effects. So this ultimately ends in the consumer paying more for television sets and cars and what we see today. So some things like furniture, clothing, household goods may still be relatively easy to source for those kind of manufacturing companies, because things like lumber, fabrics, plastics, they're basic kind of commodity materials. But however, in a technology manufacturing company like Corning, It's harder to find alternative sources for sophisticated machinery, electronics, and other goods that incorporate those components, such as electronic displays, precision casting, and precious metals. So anytime that we need those specialty materials, it's very difficult for us to find alternate sources of those things. So what leads us to the need for digital solutions like a data lakehouse? So first, we have to identify the problem in order for us to determine the right solution. Better inventory management to build the right inventory at the right time, right? You don't want to be building up a bunch of inventory, creating a bunch of products if nobody's going to buy them from you, because that just creates a huge inventory issue, too much cash invested in that inventory, and no money out, no ability for us to sell those things to our end users. So building that inventory, manufacturing those things at the right time. So we use the data lakehouse and the huge volume of transaction history that we can collect from our supply chain systems to look at the inventory, to look at how we should change prices, and look at all that information together, tying it together in the lakehouse to create that total visibility. We automate manual efforts as thousands of products come off the line every day. So another use case I'll talk a little bit about is using machine learning to quickly identify what products have defects and how they need to be reworked before we can ship them to the customer, or avoid actually shipping those to the customer, because we don't want the customer to ship those back. That incurs additional cost for us. Other things that we use the lakehouse for: advanced forecasting techniques to ensure the right product is made at the right quantity at the right time. And as always, with the shortage of our digital skill sets and employees, making sure that we're focusing on only value-added initiatives and having our employees and our data engineers only focused on those high-value initiatives. Otherwise, we can't afford to have our resources working on things that we don't understand the full return on investment and value of. So after you've identified what your business problems are, then you need to understand what capabilities need to be there in order to meet the needs of that business problem. So we needed to collect a lot of data so that we can analyze process breakdowns and financials to understand where our issues lie. So collecting and storing a lot of data means that we needed a big data system, one capable of storing petabytes of information and also capable of crunching all of that data through statistics or machine learning to help us identify where we need to improve. So our traditional data warehouses, our Oracles, our SQL servers, yes, we have those, but they ended up breaking down over time, right? So data was typically downloaded out of those warehouses into an Excel spreadsheet, and somebody was trying to do some analytics from that, and eventually on the local machine, the data was too cumbersome, the volume of the information was too cumbersome for the compute power of that machine. So we really love the fact that the data lakehouse is in the cloud on a distributed system that we can add as much resource to as we need. And to pipeline all of that data into our system, we have to build enterprise-grade tools that are capable of collecting large volumes of data and automatically pipelining that data so that we don't have to focus on the data wrangling, we can focus on the analysis. And the last capability that is critical to ensuring that we move fast and can change in this unpredictable world is leveraging Agile. Agile helps keep us accountable, organized, and ensure we're getting the customer exactly what they need. So why the data lakehouse? So first I'm going to talk a little bit about a data lake versus a data lakehouse. So a data lake has all the benefits and ability to ingest structured, unstructured data like images. It gives us the ability to access the information through APIs, and we can explore that data and do machine learning on it. However, it is limited in its ability to be properly governed and could eventually turn into a data swamp. The other thing that's a problem with just a data lake is that it's very difficult for our business intelligence users to leverage the data lake. They have difficulty understanding the structure of the data lake. It is not intuitive to them. It's difficult to connect to information with Tableau and Power BI and some of these other tools. So what we decided to do is very early adopt the data lakehouse, I think as early as 2020, from Databricks. And the data lakehouse, in contrast, has all of the properties of a data lake, but it also allows for those business intelligence users to do what they need to do from an analytics perspective. Also, data exploration for our data scientists, machine learning capabilities for our machine learning software engineers, and everything coexists together. So I'm not taking data and putting data in two different places. I'm putting the data together in one location, and then I've got all these different personas that have access to that information together. The other benefit here is that the data lakehouse has all the properties of your traditional data warehouse, but also, in addition, the machine learning components and highly reliable transactions with ACID properties. So it is really the best of both worlds coming together to drive efficiencies across our enterprise. So here is our standard medallion architecture for bringing data into Databricks, using it to do machine learning, business intelligence, and even application consumption. So I'm going to walk through some of these 9 steps so that you can understand what you see here, but each of these 9 steps represents the flow of data through our environment. So more specifically, I'm going to highlight a few things. To walk through an example, we pipeline data from several different databases, whether they're cloud or on-premises, into the Databricks environment. We take all of that data from those source systems, whether they be ERP systems, Salesforce.com systems, other marketing systems, Google Analytics, et cetera, and we bring all of that information into AWS S3, and we land that data there because we leverage AWS as our cloud. Then what we do from there is we pick up that data and we write the raw data to bronze. So you see the bronze, silver, gold layers there. The bronze tables are actually automatically written. So I didn't want my data engineers to be focused on having to take data from the raw systems and spending all that time to create the tables that were necessary to just get yourself a basic table as it exists today in the source system. So we actually have an automated CI/CD pipeline where the data is picked up from those files, those Parquet files, and automatically written to Delta tables in the bronze layer. Then that actually saves us time so that our data engineers can focus on the true analytics, right? This literally will save us hundreds of hours of time because we've landed at least 1,000 tables in the data lake at this point. So then the data gets enriched in the silver layer, and the new tables are created there, and this is for our analytics teams, for our data science teams, and for some of the machine learning and other exploration. Then that final layer is the gold layer, where the data is aggregated and refined down into smaller, more consumable tables so that things like Tableau and Power BI can actually leverage those. The data in the silver and gold layers can be consumed by machine learning as well, and actually applications directly through APIs. So we've used the data lakehouse for many use cases, including machine learning for image recognition, as well as predictive demand planning. We leverage the data lakehouse to provide inventory visibility across the enterprise and build algorithms that can recommend inventory targets for optimal cash flow. The data can be leveraged by scientists and business intelligence users alike, helping our enterprise spend less time wrangling data and more time analyzing it to make good business decisions. These capabilities have helped Corning get through the pandemic and work through the ongoing supply chain crisis with better information available at our fingertips. So now I'm going to turn things over to Brad, who will discuss driving AI.
Thanks, Heather. So, get my lighting here. So Heather explained our overall process for capitalizing on this, this notion of data-driven value creation opportunities, right? We're not here to boil the ocean, let's say, with things like data governance. It's about focusing on digital transformation and the financial impact that actually motivates you to invest in it, right? So it's all about the value creation potential in aggregate of all the work that you're doing. So, you know, the new tech that we need to apply through Databricks, it introduces some fundamentally new ways of addressing those opportunities. But anyone working in manufacturing, they'll tell you, right, they're no strangers to making data-driven decisions. There's a well-established history and a discipline in terms of continuous process improvement in that portion of a business, right? So we need to figure out how to leverage that, and that was really the key challenge for us. It's about reinforcing already established process improvement expertise and culture with a whole new set of tools to make the continuous improvement efforts significantly more productive. So there's something called Industry 4.0. This has been kicking around the manufacturing sector for a decade or more. It originated in Germany. There's a US variant of that called Manufacturing 4.0. It's a global initiative to transform the manufacturing value chain. Manufacturing equipment and systems have been digital in some form or another since Modicon introduced the first programmable logic controller in 1969, believe it or not. Right? There's always been some form of digital for the last 2 generations, I would say, in manufacturing, but it's been fragmented. It's been kind of pockets, controls focused, tactical, right? It's focused on what do you need to actually run the manufacturing operation, not what do you need to analyze and gain insight from that manufacturing operation. So for example, you need to control the equipment. You need to be able to process an order. You need to be able to schedule production in some way, and then you need to be able to handle all the logistics once that order is completed. And that is really what digital meant to most manufacturing organizations probably the last 50 years or more, right? Continuous process improvement, lean manufacturing, these types of things, including overall equipment effectiveness, this thing called OEE. If you've ever worked in the manufacturing sector, you may have heard that metric before. That stuff's been around since the 80s and 90s. A guy named Seiichi Nakajima published a book in 1985 that described how to understand the effectiveness of a piece of equipment. Was it running at capacity? Was it available and reliable? Was the yield of the process effective or not? So you don't need to teach manufacturing organizations how to use data. They know how to do that. The question is, how do they leverage the technology effectively that you're bringing to the table? What is it that you're doing with all of this advanced analytics stuff that makes them more effective at what they already know how to do? So, advanced analytics done right dramatically reduces a manufacturing organization's focus on wrangling raw data, which is what most process engineers are accustomed to doing. The last couple of generations of process engineers will grab raw data, they'll dump it into a spreadsheet, they'll do some calculations, and then they'll figure out. They'll use that to try to guide their thinking in terms of where to do process improvement. They'll also rely heavily on experience. They'll think about the input variables on a process, the output variables on a process, and through experience try to understand a correlation between those things. Not always with a lot of specificity in terms of the data, because it's just too difficult to do that kind of analysis traditionally. So, one of the cool things about the medallion pattern here, it does a really wonderful job of illustrating how to use this, get rid of this wrangling problem, right? And just move away from the raw data and this emphasis on hoarding raw data and the value of raw data, to process data, the right data that you need to make an informed decision, right? So it's not about the bronze table, it's about the question you're trying to answer and the goal table that you need to answer it effectively. How hard is it to get that goal table put together, right? How many questions are you asking? What is the velocity at which you're getting your answers? Does it take you weeks to run an experiment, or can you get something done in a day? That's really the key challenge in manufacturing. And we think Databricks and advanced analytics technology, big data, pipelining, all that stuff that we all talking about at this conference are absolutely key to transforming manufacturing. So, I mean, just net this out. For a real process engineer or someone on the factory floor doing their job in manufacturing, we tell them, focus on the right questions, work to build the goal table that you need. That's the job. Everything else is noise. Everything else is a distraction from their core mission. So, this is an interesting thing about manufacturing and applying big data. You know, these web companies that have created a lot of this tech, this was essential to their business model, right? They're data-driven businesses from the ground up. So of course they led the vanguard in terms of creating this new tech. And they open sourced all this tech, right? And they leveraged other web companies' open source as well to deploy with velocity and improve and really get effective at managing data. How do you get that benefit into a manufacturing organization? That's the management challenge, right? So, I mean, it should be no surprise that these web companies figured out how to do massive scale data because they had the SWEs, the software engineers, they had the site reliability engineers to manage these large scale systems. Most manufacturers don't do that. They've got the superpower elsewhere, right? There's 170 years worth of Corning innovation. It's an R&D organization through and through, culture, scientific method locked into everything everybody does. But there aren't any pro coders around. Where are all the pro coders? That is the key challenge. How do you leverage both? How do you transform kind of the analytics platform into something that is consumable by these domain experts? So beyond the deep cultural challenge is a successful digital transformation. It's really my opinion that scaling advanced analytics in a manufacturing company like Corning, even with this disciplined focus on scalable value delivery, right? Heather talked about that in her portion. Even with that, it's a technical challenge that cannot be practically achieved with reasonable velocity without professional software engineering expertise. So this is how we kicked it off. We needed a pro coder team to kind of get the ground running. And then we had to raise the gauntlet with these folks, right? We had to basically say, look, the challenge is for you to disappear into the background. You need to build something so reliable, so consumable by the domain experts that are actually creating the value here that you literally fade into the background. It's not about it's about the work that you enable others to perform. And that's how we get the value that we're looking for. So when we talk about things like end-to-end data governance and lifecycle management, we do this through agile software development practices. We do this through inner sourcing. So we focus on software engineering patterns, which I'll talk a little bit more about, and generalized reference implementations on those patterns. We need to crack the code on getting those pipelines built, because it's not up to the domain experts to go do that. It's up to us to just make that problem go away so that they're not spending their time thinking about that. They're spending their time thinking about their process expertise. All right, so in practical terms, here's the bottom line on this. The data that they need, that these process experts need, it's already landed for them, right? When we crack the code on all this stuff, we go through all the major data sources. We take an approach there that's highly productized. We end up with a supportable kind of infrastructure for data management that gives them the data that they need pre-processed. All the raw data sources that are required are already enriched, landed, ready to load. You don't need to go hunting for data. You don't need to go to a machine and tap into something and do it by hand. It's already done. And that is a major undertaking for a manufacturing organization, as you can imagine. All right. So these heavily productized data pipelines then make all that work go away. There's really no need to focus on this stuff. It comes down to them focusing on their domain expertise, as I said earlier. You need to get out of the way for this purpose. So if the effort required for them to get the data they're looking for is minimized, then obviously they have more time to do the actual analysis that's required. And it's literally that simple. We get a value multiplier from having experts' time freed up to focus on solving more problems, right, in a given time frame. And it's literally that driving force that gets us the value that we're looking for out of these investments. So at the end of the day, once they get accustomed to this, they're focusing on acting on insight that they glean from building their gold table, doing the analysis, running an experiment, and then seeing the outcome of that. Lather, rinse, repeat. Do it over and over and over again with velocity. If your study took you, a process study took you 2 weeks to do, it's taking you 2 days, right? 1 day. I mean, this is phenomenal. The impact of that to a manufacturing organization is kind of hard to measure. And you can imagine what the morale impact of that is as well. Okay. So, this is really what we've been up to for the last 3 years. It's just trying to make that happen. One division at a time, one plant at a time, one domain expert at a time. So, as I said earlier, Corning's a research company. Research, development, engineering, scientific method, it's just part of the DNA of this outfit. So this was, as someone recruiting software engineers into this organization, what you find is continually this amazing level of gratitude and acceptance. Once they see the results of what you're doing, they hunger for it, right? It's like, oh my goodness, this took so much effort. I did all this data wrangling because I was forced to. I had no choice in the matter. I wasn't hired to do this stuff. I was hired for my chemical engineering background or my optical physics or material science. And that's what I really want to do. So we have people doing physics-informed neural networking. I mean, all over the company. They get started, they get an experiment going, the data's ready to go, and they're off and running. And you can imagine the potential of that, right? Advanced control systems. We do all sorts of simulations of specific physical processes, which I won't get into. But the implications of learning from those experiments because the data is available, it's a game changer. So getting back to that SWE, SRE thing, there's no free lunch here. This is a manufacturing organization. Their core discipline, everything is centered around material science, not software. So there is an executive challenge, which was laid out by our CTO and our COO and our CEO, which was we need to elevate software engineering to a critical core competency in this company, right alongside material science. And to their credit, that's exactly what they've done. And so this professional coding organization makes all this stuff possible, but as I said, their job is not to change the way these businesses operate. Their job is to enable that free flow of data analysis and that increase in velocity of all of that activity. All right, so actually, let me back up 1 second here. A few other things to talk about here. This is really our core process. It's kind of a 4-step thing. And we do the pattern investments. We do targeted evaluation of projects based on their potential, their value potential. And when we evaluate a project for funding and support, it's not just about what you can do tactically with that one project. It's what is the scale potential of that? So if you prove this out and it works, right, how do we rapidly scale it out, multiply it, and make it work? And that requires us on the pattern engineering side, obviously, to prepare for that eventual scale rollout, right? We've got to sit down and make sure that the supportability of what we're doing is present, that we're not putting ourselves in a situation where we're adding complexity as these systems get deployed. Heather talked about imaging analytics. There's a great deal of work that we do with factory imaging systems where we're now introducing deep learning. And it's been immensely successful, right? We can actually propagate and cascade that stuff down further. There's this little tagline that we use also about industrialization versus artisanship. It's very common in the manufacturing sector culturally for folks to really take a project approach on stuff, You work with what you have to work with, you get your project done to improve your process locally, but what if you need to do that or replicate that work that you're doing across, let's say, 30 manufacturing lines of very similar architecture? How do you actually standardize that? How do you take your playbook and then roll it out to 29 or 30 other lines? And how long is it going to take you to do that? If you're taking this artisanship approach to the problem, It's like mass manufacturing in the 1800s, right? Everything was handcrafted until automation came into play. Then all of a sudden the parts were interchangeable. Same thing. So we have to take that industrialization approach, and again, that's where the pro-coding comes in. So as far as scaling this stuff out, we've got our playbook. We know how to, after 3 years, we got this down. So, the proofs of value get selected and done. We work with the businesses and the functions on the value potential of what they've basically promoted out of that POV. And then we decide mutually on kind of the rollout of that stuff, and then we move forward. We move forward from there. So the financial impact that we were talking about earlier, it comes along for the ride. That's how we get the transformation payback for all the investment that we're making. And with that, we'll open it up for questions. Yeah. And we are hiring those software engineers and data scientists, and so if you're interested, please reach out to Heather and I. Thank you.
Perspective of sourcing of information, sourcing of data, and sourcing of product. That's one of the, because I work for a food manufacturer, so we have constant churn on those questions. And so I'm very interested in your journey and seeing how this kind of came about. And we're just at the starting point. So I guess my question is, when you're framing your teams around the agile approach and whatnot, I'm assuming you've got product owners and whatnot involved. How did you manage kind of the scale, especially once it started to scale up? Because I know from our perspective, we've talked about, well, we got a proof of concept, and all of a sudden, there's a little bit of success, and now the flood comes in. And how did you have that same issue, or have you experienced that same type of issue?
I'll take a quick step at this, and then if you want to contribute, Heather. The one thing I'll point out here in this process is the scale pilot phase, right? So we actually hit the pause button. So we validate, obviously, the value of the data-driven insight that's made possible through all the advanced analytics that we're doing, right? The pipelining, all of this, right? We have multiple data sources that factor into this. We get a lot of process context that needs to be factored in when they're out there figuring this stuff out. So assuming that POV pays out, the next step is, all right, how sure are we that this is repeatable? Because, like as I said earlier, let's just assume, for example, you have 30 copies of a manufacturing process. You're going to take something that you built for one system and you're going to multiply that times 30. Really? How many people do you think you need to support that? Do you have the observability into what you built, for example? Does it self-heal, right? There are all of these kind of basic software engineering questions about a large-scale distributed system that you just need to answer, and this is where the scale pilot comes into play. So we hit the brakes on that, right? So if the demand pops up, we've got to basically say, yes, we're ready, or no, we're not. And then we need to give, obviously, a realistic timeline to make sure we are, if you want to add.
Yeah. I think, we definitely leverage Agile in everything that we do. As I said, we focus a lot of our MVP process on getting the return on investment for, let's say, for one plant. And then as we think about getting that out to, we have over 75 plants in Corning, so we want to replicate that into another 5 plants, for example. So we have to make sure that whatever pattern that we're developing is repeatable and reusable in that next plant, and getting the business buy-in from each of those plants that they will do it the same way. Because if they don't, that is a major problem for us to be able to scale, right? You can't all be, what'd you say, artisans, Brad? Yeah. We have to be able to reuse code and do repeatable pipelines and leverage these things in order to truly scale. Are we completely there yet across the company? No, but we're on our way. We've scaled a few things out. We've picked some very specific use cases with a high return on investment for us to do this journey.
It's the maturity of all the building blocks, right? The speaker this afternoon talking about Legos. Are the Legos, do they keep their shape? Can you really attach them? Do they are they viable? I mean, can you really support them or not? Do you even know what's going on? Do you have observability into what you've built? I mean, that's just a basic question, right? And then the other one is around, is software engineering core competency within the factory itself? Is this something that you expect them to manage on their own when they're trying to get production out the door? The answer to that, usually for a lot of manufacturing companies, is that's not something that can be expected on the plant floor day to day. You need to keep, the system needs to be robust enough that they can just do their job as opposed to try to troubleshoot some complex system. If it's not reliable, it'll get shut down. Because at the end of the day, it's an advisory component, right? It's not part of the core process itself.
We're out of time.
Awesome. Thank you so much,
Thank you, Walt.
Heather and Brad. Really appreciate your time, and thank you so much for being here.